In the fall semester, we talked about functions and relations, and we said that a relation is actually, a mapping or a pairing um, between the set of input and a set of output. So today what we're going to look at is how to find the inverse of a relation. We're going to break it down into two parts. So say, for example, you have here a relation represented by ordered pairs, and to find the inverse, if you want to find the inverse of um, a set of ordered pairs, what you're going to do is to switch the coordinates of the ordered pairs. So in other words, if the original ordered pair is -4 and 7, so just switch them around. So the result when you switch all the coordinates around is what you call the inverse relation. Now, ordered pairs can also be represented by a table of values. So if this is the original, table of values, in order to find its inverse, do the same thing as you did for the ordered pair, just pretty much, switch the x and the y values around, and the result will be the inverse. Now, since you can interchange the set of input and output for tables and ordered pairs, I think there is also value in looking at how you can switch the input and output on, let's say, for a given function. So in number one, you know that f of x, which is the same thing as y, okay, so number one, you have x minus 6, right? Now, is it possible to get or isolate the input instead of the output? Because usually the y value or the f of x is the one that's separated. So what if we want to isolate the input? Is that possible, and how do you do it? Well, this means that, you're just pretty much solving for a specific variable. So in other words, you just have to solve for x. You have to isolate x, in other words. So here, if you isolate x, what will you do? You have to move the 6 over. So you will have y plus 6 is equal to x. So it says here solve for x, we've done that. And then find the input when the output is 4. So what are we going to do? Where are you going to substitute 4? The output is the y, right? So if you substitute 4 plus 6, what is your input? So this will become x is equal to 10. So this is the formula for the input, and this gives you the value of the input when the output is 4. Okay, let's try number 2. So changing f of x to y, we have y is equal to half x plus 3. So now let's get the x by itself. So how do you do that? Move the 3 over, you get y minus 3 is equal to half x. And then how do you eliminate the 1/2? So you're going to multiply both sides by 2. So these will cancel out. And you're going to multiply this by 2. So simplifying further, you get 2y minus 6. So if you substitute 4 for the output, 2 times 4 is 8 minus 6, that's 2. So when the output is 4, the input is 2. Let's look at number 3, I'll do it here. So changing f of x to y, we get y is equal to 4x squared. Divide first both sides by 4. So y over 4 is equal to x squared. So how do you remove the power? You get the square root of both sides. So let me scroll this down so we'll have more space. So this means it will be equal to y square root of y over 2. No more radical over the 2 because the square root of 4 is 2. So when x, or find x when the y value is 4. So what's the square root of 4? 2. 2 divided by 2 it's 1, right? And last but not the least, changing f of x to y, I get y equals 2x plus 1. Now, isolate x, so move the 1 over. Y take away 1 equals 2x, and then divide both sides by 2. So x is y minus 1 over 2. Changing y to 4, 4 minus 1 is 3 over 2. So x is 3 halves, or 1.5. So that's how you find or you solve for the variable x, or for the input of a function.